half-life of iodine 131 is 8 days. So that means no matter how much you start with, after 8 days you will have half as much as you started with. So find the continuous decay rate K in the exponential formula f of t equals a e to the kt. So we're using this setup because we're told that we're looking for a continuous. Continuous is always our clue that we're going to be working with our base of e. So what we're looking at is here we're going to start with some initial amount a. So we're looking at how long does it take to have half of that. We could call that just 1/2 times a. So no matter what a is, we want to have half as much. So we know that it takes 8 days to go from a to 1/2 a. So for this change to happen, t is equal to 8 to go from a to 1/2 a. So we're going to plug this into our formula and solve for k. So our ending amount, we're going to have 1/2 a, half of what we started with, is equal to the initial amount a times e to the k times the amount of time it takes for this change to happen, which we were told would be 8. So we can start out dividing both sides by a, whatever that initial amount was. We're left with 1/2 equals e to the 8k. So we want to solve this for k. So the natural log of 1/2 is equal to the natural log of e to the 8k. So when we're solving an exponential equation, we can use the inverse operation of logs, applying that to both sides of our equation. Our properties of logs allow us to take this 8k and move it out of the exponent out in front as a coefficient, and then we'll use the definition that the natural log of e, log base e of e, is always equal to just 1. So we have the natural log of 1/2 is equal to 8k times 1, and then dividing both sides by 8, we have that k is equal to the natural log of 1/2 divided by 8. When you're working problems like this where you need to find the value of k, I encourage you to keep a lot of decimal places in your calculator just so that you avoid any rounding errors in your final answer. So just keep as many decimal places as your calculator shows when you're finding k, and then we'll round at the very end when we're looking for our final answer. So we get that k is approximately negative 0.086643398. So this is our continuous decay rate k. Think about what this is telling you. It's negative since the amount is decreasing. This is telling us that our substance is decaying at a rate of approximately, if we round it off here, so think about moving your decimal place 2 places to the right, about 8.66% per day. So k is telling us our continuous decay rate. Our time here is measured in days, so it's decaying or decreasing at a rate of about 8.66% per day. Now that we have found our continuous decay rate k, we can use our formula to answer additional questions about this particular radioactive isotope. So we want to know how much will remain in 20 days, so this is going to be our value for t. If we started with 30 grams, so this is going to be our initial value, a is going to be equal to 30. So we want to take those values and plug them into our formula. So we're going to be evaluating our formula for an input value of 20. It's equal to a, our initial value, 30, times e to the k. K is what we just found in the last step. So negative 0.086643398 times t, which we were given to be 20. So as we plug this in to our calculator, watch for rounding instructions in a given problem. This one didn't specify, so we'll just go ahead and go to the nearest tenth here, that it's about 5.3 would be our output. Since our initial value was measured in grams, this would be in grams as well. So if you started with 30 grams of iodine 131, after 20 days you would have approximately 5.3 grams remaining.